All right, so yesterday we started our discussion on exponential functions. So an exponential function is of the form a to the x power. Now we'll see where we get today, but like all of our other functions, we can manipulate this function to, and it'll change its properties. The general shape of the graph will stay the same, right? But like, when we're dealing with the squared function, okay, with parabolas, when we add or subtract, or if we're multiplying, okay, that changes the shape and the position of the graph. It might make it skinnier, it might make it wider. It's still a parabola. It might flip it upside down. All the different transformations that we can apply to it. So yesterday we took a look at the graph. Okay, so here we have an exponential growth graph. Right, so over on the left side, it's very, very small. All these numbers are less than 1. Okay, because remember, when we take a negative exponent, that means that we're getting a fraction. Okay, we talked about the domain. The domain was all real numbers. You can plug in anything you want as long as it's a real number in there. And for these basic functions where we have, just a number to the x power, the range is positive, okay, greater than 0. It will never be 0. You cannot raise something to a power and have it equal to 0. Okay, you can get very, very tiny fractions. If I did 2 to the negative 10th, that would be 1 over 200. No, 1 over whatever 2 to the 10th is, 1 over 1,000, something. Right, so we get closer and closer and closer. So another thing that we can say that I'm going to add on to our range is that our exponential functions, tying it to our last lesson with rational functions, exponential functions technically have a horizontal asymptote. Okay, so there's that invisible line here. That just happens to be the x-axis in this case, right, that we can't cross. We'll get infinitely closer to it, right, 0.00000000001, but it'll never be 0. Okay, so let's start off today with looking at a slight variation. Okay, on reflection, a to the negative x. Right, and let's compare it to what we did yesterday. Yesterday we did 2 to the x, so let's take a look at 2 to the negative x. So we're going to make a table, and we're going to graph it like we did yesterday. Let me move that over a little bit. All right, so again, the reason I'm drawing the graph like this, and I'm not involving the lower numbers, oh, that's a really crummy graph, sorry about that. That's a little bit. Right, is because we still have that asymptote. Okay, what we're doing is we're reflecting it in the x values. Right, so let's take a look at what happens. So we're going to pick some numbers. So now, because I have that negative attached to the x, we're changing the sign of all of our inputs. So when I input -2, I have 2 to the negative 2 power. Right, so anytime that happens, that becomes positive. Right, so at -2, I would have 2 squared, which would be 4. Right, so at 2, I have 4. At -1, when we plug that in, that would become 2 to the first power, which would be positive 2. When we plug 0, 0 doesn't matter. Anything to the 0 power is 1. Okay, so that matches up with what we had yesterday. And now when I start plugging in positive numbers, okay, that's going to get me my fractions. All right, so when we plug in 1, we get 1/2. When we plug in 2, we get 1/4. So now over on this side, it's getting closer and closer to 0. Okay, so there we have our reflection. Okay, I almost said inverse, but technically it's not an inverse. Right, so anytime we see this, okay, it's a reflection over the y-axis. All right, we flipped it from one side to the other. So, you know, just for comparison, color pencils, our regular function, okay, this would be 2 to the positive x. All right, so there we can see how it is a mirror image, right, over the y-axis. Okay, it is a horizontal reflection. Okay, so right, we'll get to that point next week. All right, so let's look at other transformations. Well, first, let's take a look at what happens when we change the base. All right, so let's bring up. So let's take a look at 2 to the x, all right, since we looked at that yesterday. All right, so there's our normal exponential 2 to the x. If I change my base, let's make it bigger. Let's make it 5 to the x. Okay, you can kind of see that it shoots up faster, right? We're multiplying 5 by itself instead of 2. Well, obviously, that's going to increase at a higher rate than the 2 will. Okay, but also it ends up, you know, it's not really a mathematical term, but it ends up dipping faster than the other one too. Okay, so it's more extreme when we have a larger number. All right, let's just do one more. 10 to the x. Okay, that's extremely steep. All right, before you know it, it gets out of hand, and you know it's almost a vertical line compared to the other two. All right, this was our 5x, and this was our 2 to the x. Okay, now for our base, we're sticking with positive numbers, but they don't have to be whole numbers. Okay, I can do 1/2 to the x. Okay, well, let's take a look at this for a second. That kind of just looks like what we just came up with. So let's talk about that for a second. All right, so we have, actually, yeah, let me get rid of this. All right, so 1/2 to the x. Right. Well, if I deal with this on the inside, 1/2. Another way of writing 1/2 is 2 to the negative first. Right? So if I have 1/2 x, I could rewrite that as 2 to the negative first times, oh no, my pencil, to the x. And then going back to algebra, when we raise a power to another power, we multiply those. Look at that. Okay, we have 1/2 x is the same thing as our inverse. Not inverse, reflection, okay, to the negative x. Okay? And that's true with any of our fractions that have 1 over something. Okay, so if you had 1/4 to the x power, well, that's the same as 4 to the negative x. All right, so let's make a general rule. Okay, where we have 1 over a to the x, well, that'll be a to the negative x. Okay, let's test it with a maybe 1 or 2 more. Let me clear these. All right, so let's do maybe 1/5 to the x. Okay, well, that's the opposite. That's a reflection of 5 to the x. So we could also do 5 to the negative x. And, well, they're the same line. All right. So if you see it one way and you don't like the way it looks, you can change it to another way. Okay. If you don't like dealing with fractions, you could change that to a negative exponent. Right. And it would behave the same as that we saw it. Right. So 1/5, if we were doing it algebraically, right, if I did 1/5 squared, well, I would square the numerator and the denominator, and I'd get 1 over 25, right? So that matches up with what we had on our graph. If I did 1/5 to the negative squared, okay, well, that's telling me, again, anytime I have a negative exponent, that means we take the reciprocal. Okay, so 1/5 to the negative second gets us 25, right? And that would be on our left side here like that. Right? So if we change our base, that kind of changes the steepness of our graph, right? And then if we make it negative, right, that reflects it. So let's take a look at some other transformations. So one thing that we can do is what letter do I want to call this? Okay, I can add to the exponent. Okay, when we add to the exponent, okay, if you're going back to algebra, when we have an addition or subtraction on the inside, okay, that gives us a horizontal shift. Right, so let's just go back to our basic function here. Why is it doing that? All right, so let's take a look at 2 to the x. Now what I'm going to be doing is I'm going to be adding a to it. Right, so as a, oh, that's right, I forgot. This moves in opposite direction, right? Right, so if I'm subtracting numbers from it, right, so here you have what the function is. 2 to the x minus 2, well, that moves my graph over from the original, right? Here's my original at just 2 to the x. Actually, let me keep 2 to the x there. All right, so that blue function is my original to the x. Now, as I'm subtracting numbers, it moves it to the right, okay? And we can see the shape of the graph isn't changing. It's just being moved. When I add to the exponent, okay, it's moving it left. Right? right? And that follows all the rules that you learned back in Algebra 2 when you were manipulating your parabolas and whatever we had, and at the beginning of the year when we talked about this. Okay, so when we're adding to the exponent or subtracting, okay, that's going to be a horizontal shift, right, like we have here. If we're doing something to the outside, so if I have a to the x and then I'm adding or subtracting after the fact, okay, just like our other transformations, that's going to be a vertical shift. All right, so let me get rid of that. 3x plus a. Okay, now, right, there's our original, right, 2 to the x plus 0, right? It lies right on top of that blue one. And now it goes in whatever direction. So when I add on the outside, it's moving it up. Okay, so I kind of change that. I change a few things here. Okay, when we're adding on the outside, I'm changing the y-intercept, right? So when I add 1, everything's moved up 1 unit, right? So my y-intercept here was 1. Well, because I added 1 to the function, now my y-intercept is up here at 2. What it also does is it changes that asymptote, right? Now my asymptote's no longer at x equals 0. I'm sorry, y equals 0, right? It's not that flat line anymore. Now your asymptote is going to be wherever this addition is, right? So if it's at plus 1, my asymptote is at y equals 1, right? If I drop it, if I'm subtracting 3, okay, it moves my y-intercept down 3 units, and it moves the horizontal asymptote down 3 units. Okay, so now my horizontal asymptote is at y equals -3. Right? We saw what happens when we flip it with a negative up here. So now let's take a look at one more thing. Right, so we had our reflection over the y-axis. Well, we can reflect it over the x-axis as well. So here we got to be careful with our parentheses. So technically, this is negative a to the x. All right. So that, right, there's a negative in front of there. This gives us reflection over the x-axis. Right, so let me clear this again. So we have 2 to the x, our original there. So now I'm going to do -2 to the x, right? So there's our perfect reflection. So the reason I said you got to be careful with the parentheses, if I did parentheses -2 to the x, it doesn't give me anything. Okay, that actually I don't know why it's not giving me anything. Normally it would give us kind of this weird kind of wavy function, right? Because you would have 2 to the 0, that's 1. 2 to the first is -2, so you would drop down there. 2 to this -2 to the second would be +4, so it would be back up and then down and then up and then down and then up. So here, this is different than -2 to the x like that. Okay, that negative is being applied after you do whatever this is. right? So this is, if you had negative 2 squared, you would do 2 squared, which is 4, and then that would be negative 4. Right? So here the parentheses matter. Right? And there again we can see they're mirror images, right? And our reflection line is the x-axis this time. Right? So we can perform all of our transformation operations on this, just like we did with our normal polynomials and other various functions. Okay, yeah, I'll save that for next week. All right, guys, any questions about this?
No.